In this video, we're going to look through Topic 8, Lesson 3, Data Distribution, the second day of that. So we're looking at the second half of the content in the chapter. So our objective is still the same. We'll be able to find measures of center and spread and compare data sets using statistical measures that are appropriate for the distribution of the data. And so we're going to go a little bit deeper into some symmetric distributions. So we just used a general symmetric. The symmetric distribution that we're going to spend the whole next section on is called the normal distribution. The normal distribution is a bell-shaped curve. And so notice that this shape of this graph below looks sort of like a bell that is symmetric about the mean. That's called the normal curve. Approximately normal distributions can be found in many real-world situations. Think about these as things that are naturally occurring. Thinking about it as like height and weight measurements. And other measurements of really animals. Or plants or any kind of living thing. So something that isn't man-made. Think about it that way. A uniform distribution is a distribution in which all outcomes are equally likely. Usually this is data such as drawing a card, spinning a spinner, rolling a die. So these are like probability related. It's also called a rectangular distribution because it looks like a rectangle because it is uniform. Everything has the same outcome. So in this first example, what we're doing is just identifying whether things are normal. And so for these, they give us a graph too, just to kind of lend us a hand in deciding whether or not they look normal. But really we're talking about if it's normal, it's a measurement of something that is not man-made. And that will provide us kind of a clue as to whether something should be normal or not. So in example 3a, we have the heights of all people in a large group. So looking at this distribution, we can see that there are outliers. So it's not perfectly symmetric, but that red line shows us that most of the values are in the middle. And so this is something that we can consider a normal distribution. And ultimately, just from looking at this heights of all the people in a large group, right, just that idea, the height is something that is made by nature, not by man. Okay, so that would say that this would be something that is normal. For B, we've got the probability of landing on each of 8 equal parts of a spinner. And so notice that this looks like that rectangular distribution, right? The best shape for that is a box. So this one is not normal. And so ultimately, think about this as if they're equal parts, that means that each outcome has the same probability. Which is the definition of a uniform distribution versus a normal distribution. The scores on an easy test, so if you think about it as an easy test, the scores should be high. Right, so all of the scores should be on the right side. So that means that this would be something that is not normal. Normal would be where all of the grades are in the middle. So if I think about that, that looks like it's skewed left. And then if we look at D, this looks the opposite, right? I could think about this as being skew right. So the number of children in a family is something that is not normal. So we don't have a lot of people that have a middle number of children. A lot of people have less children, right? This is showing us that more families have less children. So those are some examples of things that you will see and have to determine whether it is normal or not normal. So ultimately this could be, you know, a multiple choice question, which I believe is how it will be on the unit test, that you're asked which of these is likely to have a normal distribution, right? So our answer would be A in that case, because the rest of them were not normal. So that was the new piece. The back of this is actually just review from what we did in the last lesson, where we were talking about the measures of center and the measure of spread. So this is asking us how I would classify the data. So remember, that means skewed left, skewed right, or symmetric. And then using that, I'm going to describe the type of distribution and find the center and spread of the data. And so looking at each of these, I have to have the data in order to tell. So what I'm going to check in order to determine what type of classification each of these are, I'm going to find the mean and the median. What we learned is that if they are equal, that means that it's symmetric. If one of them is larger, so if they're not equal, that means that it's skew. And we'll remind ourselves the two different types of skew when we get to that point where we're actually identifying that. So in order to find the classification, we need to find the mean and the median. And then that will tell us which one's the center. So one of those is the center, depending on if it is, they're equal, if it's symmetric, or if they're not equal, it's a skew data set. And so what we're gonna do first is take all of our data and let's put it in order so that we can find the median. So looking at this data, the lowest number here is 64. So I'm just gonna rewrite so that I have that. And then we've got 72, and then 76, and another 76. Okay, so I'm just putting that in order. I'm crossing them off as I go to make sure that I don't miss anything. Ooh, I did these a little too far apart. 115, 119, and then two 120s. Okay, so that's my data set. And so if I look at this data, I want to start by finding the median and the mean. And those two things will give me a clue as to what type of data we have. So for the median, I'm finding the middle of the data. So if I find the middle, again, I'm covering up each number with my finger so you can't see that, but you're moving towards the middle to try to find what the middle number is. And it looks like the median of this data set is the number 98. Versus to find the mean, I'm gonna add up all the numbers. So I'm gonna take and add 64 plus 72 and so on all the way. And then I'm gonna divide that by how many numbers that I have, which in this case, if I count these numbers, there are 15 of them. So if I add up all of those numbers, I get 1,456. If if you want to pause and double check that, and then there's 15 numbers. And so if I divide that, it gives us 97.06 repeating, which we would just round up to 97.1. And so what we can see from here is that if we're comparing the mean to the median is less than the median, and less means that this is skewed left. Okay, so that means that the classification of this data is skewed left. So again, if it was the opposite, if the mean was larger than the median, larger means to the right, so it would be skew right. So if I'm classifying this as skew left, that means that the measure of center of the data is the median. So the median value, which is the 98, is the measure of center. And the measure of spread that goes with median, we talked about, must be the inner quartile range. So what we're going to have to do next is figure out what is the inner quartile range for this set of data. So remember, to find IQR, we're going to find Q3 and subtract Q1 from that. Okay, so we're going to have to subtract two values. So since we have our data set, we've already found the middle. So what changes from what we saw yesterday is that this is now the lower half of my data. So I'm not looking at that 98 when I'm cutting my values in half. So when I have an odd number, that median disappears from my data set to find the middle values. So if I look at this, since there's 7 on this side, that means that Q1 is 76. And if I look at between 99 and the second 120, that means that the third quartile is the middle number, which is 115. So to find IQR, I'm going to do 115 minus 76, which gives us a value of 39. So our measure of spread is going to be 39. So our data set was skew left, which told us to look at median and IQR for the measures of center and spread. So we're going to do the exact same process for the next set of data. So let's put our data in order. So these are smaller numbers this time. Looks like our smallest number is 3. And then 2 5s. Oops, I missed an 8, sorry. Okay, so in order to classify the data, remember that we want to calculate two values. We want to find the median of the data, and we want to find the mean of the data. So looking at this, we have an even number. So if we find the middle is between the two 8s, which means that the median is still 8 because those are the same number. And then to find the mean, we want to add up all the data values together. And so if I add up 3 all the way to 14, I get 96. And then we had that even number of 12 data values. So if we divide 96 by 12, we also get the number 8. And so what we should notice from here is that to compare, this time our mean is equal to our median, which means that this is symmetric. So when it is a symmetric distribution, that means that we are going to use the mean as the measure of center, but but it was the same as the median anyway, so that means that our answer is 8. And that means that we now have to calculate the standard deviation. Okay, so to calculate standard deviation, we have to make that table, which I did not leave myself very much space over there. So I'm going to do the table on this left side, just because I have a little bit more room. So remember that the table has 4 columns. Again, if this were an assessment, it would be given to you, but since we didn't know which one we were using for which, we didn't put it on the notes, because then you would just know what to do. So remember, the first column is the data values. So we're listing all those numbers in order still. So 3, 5, 5, 7, 6, 7, 8, 8. 9, 9, 10, 12, 14. So we're just listing all the data. And then the next column is the mean. Our mean was 8. I'm just going to draw a line to say that all of these numbers are 8. Remember that the next column is I'm going to take each of those x values and subtract the mean. And then for the final column, we are going to take the x values minus the mean and square those numbers. Okay, so if we take and subtract the mean from each of these values, so 3 minus 8 is -5, and so on. So 5 minus 8 is -3, -3. 6 minus 8 is -2. 7 minus 8 is -1. 8 minus 8 is 0. 9 minus 8 is 1. 9 minus 8 is 1. 10 minus 8 is 2. 12 minus 8 is 4. 14 minus 8 is 6. So each of those values we're then going to square. So -5 squared is +25. 9, 9, 4, 1, 0, 0, 1, 1, 4, 16, 36. Okay, so remember that this sum is part of our formula. So for standard deviation, we're going to do that value sigma is equal to the square root of the sum divided by that n. That was our 12 that we used to find the mean, right? That number always matches. So I have to find the sum of all of those numbers. So if I add up all the red numbers from 25 down to 36, that gives us 106. So the standard deviation is going to be the square root of that 106 divided by 12. Which is about, hold on, I don't have this number written down. 106 divided by 12 is 8.3 repeating. And so if I take the square root of that number, that gives us a standard deviation of about 2.97. Okay, so the standard deviation is 2.97 for that data set. Okay, so if the data is symmetric, we know that by finding the median and the mean, and that those two values are exactly the same or round to the same number. That means that our data values are symmetric. When they're not equal, they're skew. So the way that that works is that we saw when the mean was less than the median, right? Less than, it means it's on the left. So if the mean was greater than the median, that would mean skew right. Okay, so this tells us right, that tells us left. Okay, so for this lesson, really the only new thing was talking about what types of things are normal distributions, and identifying that given a scenario. And then we looked more at, given a data set, finding either the mean and the standard deviation if it's normal or symmetric, and the median and the interquartile range if it was skew in any way.